Hello everybody, my name is Sharon George and today we will be discussing about quicksort. So this is another sorting method and I've written a program here in code blocks. Let's have a look at the program. We're going to discuss the program. So it's simple as usual. You begin by including the header file and then the standard library file. So here I have a function called partition1. Since partition is a keyword here in C++, I took the name of the function as partition1. Otherwise, there is no special meaning to it. And its return type is int. And I have passed three parameters, that is int star a, that's the array, int a start, that's the beginning or the leftmost part of the array, and int a end, that's the rightmost part, that's the end part of the array. So the most important part in quicksort is that how quicksort is done is that in the given array you select an element as pivot and you have to do such operation so that every element that's less than the pivot comes towards the left hand side of the pivot and every element that's greater than the pivot comes towards the right hand side of the pivot. So you can select the starting element as pivot or the ending element as pivot or the mid element as the pivot, anything. Here I have selected the end element as the pivot. So a of a end as pivot, and then there is another integer variable called partition index. This doesn't store the element but this stores the index. So I have given the starting index to store in partition index. Now I have got a for loop and I'm running it from I is equal to a start from the starting to the end and incrementing I. So now this is the condition given inside a. If a of I is less than equal to pivot, if it is less, just swap it with a of I and a of partition index and increment partition index. Otherwise, this if condition is there, because we need all the elements less than pivot on the left hand side and all the elements greater than pivot on the right hand side. If that's not the case, then swap a of partition index and a of a end and return partition index. Return partition index because the return type is int, so I have to return an integer value, and that's what the function expects. Then there is this main function called quicksort. This is our most important function. Here also we are passing three elements, three arguments: int star a, int a start, and int a end. These are the three parameters of the function. And if a start is less than a of end, the leftmost position should be always less than the right. As soon as it passes, as soon as starting and ending position passes, the iteration has to stop. So that's the reason why I have given a start less than a of end. So int partition index is equal to, I call the partition function here by passing arguments a, that's the array, a start, that's the starting position index, and a end, that's the end position index. And I'm calling quicksort function here. It's a recursive function called by itself. So quicksort a array a start, and I'm passing partition index -1. Okay, so that's the end. So from starting to partition index -1, next will be, guess what, array of course, then partition index +1 and a end. I hope you understood. It's simple, it's easy, and now the main function comes. This is just simple. I have declared an array of a of 50 and an integer variable n to take the size of the array, and then a for loop to get the elements. And now I'm calling the quicksort function with the arguments array and the starting position 0 and ending position n, that's the maximum size of the array, and the sorted array will be displayed. Okay, so this is simple and easy. I hope you understood. Let's just build and run and try to see it. So enter the array size. I enter 10. Enter the array elements: 56, 43, 30, 42, 32, 23, 21, 1, 2, 2, 1. So the sorted array is 0, 1, 1, 2, 2, 21, 23, 32, 42 and 43. That's pretty impressive. Quicksort is really good. The advantage of quicksort is that it doesn't have a space complexity of big O of n. Everything is done there itself. You don't create new array, or you don't create a new space to store the elements. So that's the advantage of quicksort in comparison to mergesort. And quicksort is really fast, not so slow in comparison to other sorting methods. I hope you understood. Thank you.